Okay, my good friends, now if you haven't seen the new statements I have been making about how we're going to proceed with Mudfossil University, I am going to make them right now. We are going to start from the very, very, very beginning of everything. Right from the beginning of everything. And what does that mean, Roger? Well, that means we're going to find out what matter is constructed of. And what does that mean, Roger? Well, it means that we're going to look into electron flood theory. I did this 50 years ago, and I realized that the nucleus of all atoms is not just one big positive chunk and then a couple little negatives floating around it. No, it was impossible, literally impossible. So I devised a theory that said the nucleus was a dipole. It had a positive and a negative, and therefore it had enough negatives to overact, to compensate for the core, and then no more negatives were allowed in. That's what kept them in their nucleus. And in their orbitals. And I will show this, well, here it is right here. This is the nucleus. Now would be helium. And instead of having 2 protons and two neutrons, gigantic chunks in here, it has 7,350 electrons. And an electron has a strong force and a weak force. They are dipoles. When you add them all together, the weak forces don't oppose anybody. They're too weak. So they get pushed into the center. The strong forces surround the outside because they want to get away from everybody else. They're pushy. They're pushy. The red guys are pushy. Get away from me. Yeah, you get away from me. And they're push to shove. Now, the black ones say, I don't care. We'll go right in the center and get away from everybody. And that's what they do. So it crusts with negatives. Then more negatives want to get to this ball of positiveness. But these negatives say, no, we're going to push you away. And they shove their way in and they get pushed away. And they say, no, you stay exactly there. That's called quantum. This little electron, which is a dipole, has some little characteristic region that it possesses, and this possesses a big region surrounding itself. And that, my friends, is the universe that we live in right there. You see that? This is the first largest 3D map of the universe ever created. Now, I have been claiming right along that you have a central nucleus made up of electrons, bazillions of them, and they interfere magnetically with a region surrounding them. So, in all practical effect, that's what you have as electrons in the ball. Now, because they are congealed into a ball, they have influence surrounding them at a certain distance. And these are the distances. And they actually overlap. You see them overlapping? You see these ones overlapping 3 different places? This is what you call a molecule. All right, now, I did this many, many years ago. This was a paper I did to try to show that there was dipoles that held everything together. Anyway, this is the overlapping orbitals, just like this. You see, this is the nucleus down here, and it holds electrons in this one, and then this one, and then this one, and then this one, and then this one, and these surround the nucleus at certain distances. Now, it appears I was wrong to some degree here. They're not like well, they are discrete distances, and we can see that in the micro scale. Now, in this macro scale, I can see they're interacting with each other in their regions, like one of them's grabbing this one, and another one's grabbing this one, and that type of thing. That's what you have here. They're interacting exactly as you would expect atoms to interact with other atoms. All right? It depends on how many particles these have, how engaged they are with their neighbors. And that's a function of how much is in the core and how much is being pushed against it, how much is being pulled. It's push to shove. There's a lot to this. But anyway, it goes on, all about these different orbitals and their interaction, non-bonding orbitals, orbitals that don't bond with other orbitals and bonding orbitals, and then their difference in, and I'm finding a lot of things I wrote in here that were not correct. And that's why I'm going over some of the new information to correct the things that I said before that weren't right. But the basic bottom point of everything I came to here was this. Bonding forces between atoms to form molecules are also electrostatic, which means a positive and a negative in nature. This means they are Coulombic forces. They're positives and negatives. They're not just one big positive chunk in the center and some negatives floating around. It does not work that way. And that's what I had a real problem with, that because I went against what I was being told to say, and I still am going against it, and I am right. And as a matter of fact, the guy wanted to give me a B because I was saying this, that you're not right about the nuclear force being all positive, and I challenged him, and I knew more than he knew about. I forget, it was some kind of dipole molecular moment of something we had to calculate out, and I beat him, and he ended up having to give me the A. But you know, you got to fight back, because if you just say what they tell you to say, that's what everybody's doing. And here's the problem: if you don't say what they tell you to say, if you're right or wrong, it doesn't matter. I got lucky because this guy, he allowed me to challenge him. That's the only reason I ended up with the A, because otherwise he would have said, you know, screw you, you're done. I don't care what you say. And he could have said that, and I was not. What am I going to do? Although I think I got kind of aggressive. Anyway, and it's all. And anyway, document what you say. Document. I mean, look at all this stuff. It's crazy. But there's everything I see now, I'm finding is wrong. And nobody will engage when you show them the evidence. I know I sound like I'm a crazy person coming up with all this stuff, but maybe I am crazy. But I'm going to tell you right now, if you want to listen to a crazy guy, I'm going to start right out with all of this. Now, I don't know what order these are in, but I got whiteboards coming out of my ears. Now, get yourself your book. Remember I told you, always get a book. Get a book and get ready to start writing down all of these different boards. It's electron flood theory, how the nucleuses are constructed. Everything's made out of 100% dipoles, electron flood theory. You can stop these and watch these later, right? You can see these now. All right, now, this is the more electron flood theory: heat, cold, water, static, ether. This is what the actual particles look like. Photons are back-to-back electrons. Those want to incorporate in things. They explode when they hit things. These bounce, and they create heat and light and so forth. These interact with the molecules they crash into. Although in their heat configuration, I don't know if they're photons or not, but in their heat configuration, they flow through things, and they don't destroy things. They just build heat. Now, if they're going in as photons, I don't know. This is all the different electrons, photons, stable electrons, groups, masses, molecules, boom, boom, boom. This is what the current nucleus is. A neutron really is 0 electron volts, they say, has no potential. And it's 838 electrons is what I say, and to them it's one neutron. Proton, they say, has one positive electron volt. And I say it's 1,837 electrons because a proton, because it's not equal, it's not neutral like 1838. That's a neutral number, same as negatives as positives. This has one additional positive. It makes it a positive force. Electrons are just one electron, and that's a negative. Now, I'm still in the midst of really dealing with this, to be perfectly honest with you. 2 protons and neutrons and 2 electrons is what they say makes up hydrogen. And I say no. That right there is 7,350 electrons. And that gives us the elegance to create all the isotopes and all that. And then we're going to get into electricity and, you know, house current, AC, and battery goes one direction, volts, amps, Ohm's law, all of this stuff we're going to get into. You should know all this stuff. Because I'm going to tell you what they say because I understand both sides of it, trust me. I understand exactly what they're saying from the physicist side, 100%. And anybody wants to confront me with that, I would love to discuss it. And I understand 100% of what I'm saying. You know, I mean, well, as much as I can understand of the other side of it, because this is pretty new. But in my opinion, we end up with electron flood theory, because I can see the photons coming out of a red laser. They look like that, back-to-back electrons. All right? Electron is just a pair of these, explosive and a non-explosive, and back-to-back they make photons, which will not kill you. Electrons will electrocute you, because they want to go right directly into the mass that they're going into. And if there's enough of them at one time, they will explode the mass. That's what happens. It sizzles and burns and explodes. Photons, you really got to get a lot of concentration of them. They're bouncy. These are like screw right through you, right into the right head. So you have a concussive value of the photons, and you have an explosive value of the electrons. But we can actually see them accelerate, and then we can see them divide from the black, which is, I'm considering that to be what they would call a muon neutrino, a black, non-reactive, weak force particle, actually separate from the reactive, white, explosive part, and the black balls just roll around the outside while the white explodes like an atomic bomb, and then they come back together. That is electron flood theory, and that is the division of forces. It's an actual charge separation that's done at the Venturi, which has enormous implications, because what happens here? Right here, we don't have anything but explosiveness. Out here, we have nothing but non-explosiveness. We've separated the values of these two attached particles. One of them is the weak force and one of them is the strong force. We have literally separated them in this Venturi. All right, so we got a lot of stuff to go over, and I've got a lot of old papers and so forth to go over that have changed, and we're going to start right now. Okay, my friends, I guess I've been tiptoeing around the edges a little too long. We're going to get in deep. We're going to talk about God, gods, lords. The ancient texts describe things pretty well, and the evidence that exists to support mythology, ancient mysteries, the things that we have always considered to be silly are now very well proven and have an enormous effect on what we need to reconsider. Now, I have giant humans. That's a giant human being. That is a new species, not DNA tested. This is DNA tested human. That's DNA tested human. It's a normal sized human lung. And I have another fingertip that's even much bigger than this. That's a human fingertip as well. Mitochondrial DNA. Obviously the father's side, something's different. But the mitochondrial side, the mother's side, same as ours. And here's the test right here that proves it. And it's not a cheap, silly little test, a swab or anything. This was taken right out of the arterial supply, and this was 3 different species. One of them was this, one of them was that, and one of them was this giant fingertip. And they were all positive for these DNA, cytochrome B gene and D loop region. Now, that's the lung and the 36-inch tip. I mean, it's just absolutely gigantic. So, what I am referring to here is well established, and there's no guesses here. The specimens are here to be tested. They've been refused by every teaching university, which is, to me, disgraceful. If they're going to say that this stuff isn't real, I have the evidence to prove it is real, and they refuse to even examine it. So, we're going to go into, but God is more important to me than all of this stuff. Now, I'm done worrying about that kind of nonsense. They have brainwashed the kids, and in order for you to become successful in life, you have to agree to everything they say. It's intimidation, extortion, racketeering is the peer review. The whole thing is just a mess. So I'm getting out of that swamp, and we're going to go into reality and see what was written about God. What can we prove about God? I'm looking into, they think they might have found the Noah's Ark now. I mean, all of this stuff was written, that's not just all jokes and silly stuff. That's the thing that kills me. They cannot allow their mind to stray into the realm of reality. That's the key. The mind of academics is identical to the mind of a person that says the earth is flat, I don't care what you show me. They say none of that stuff was real, I don't care what you show me. It's the exact same mind, just two opposite ends of the spectrum. Okay, my friends, we're going to do a whole new thing now, I hope. I need some help, so somebody just listen, please. What we need to do is start online classrooms. All right, I just spout and I just do this and that, and there's no organization to the things that I do, and I don't want to organize. But I could see creating inside of Mudfossil University, which I'm reopening my website. Hold on, it's up here, I think. Yeah, this is it right here. And that will be coming back online very shortly. Now, what I think we should do is in this website have classrooms, and you sign into that particular classroom, and then you're into electron flood theory, or you're into ancient texts, or you're into space, or you're into, you know, geology, or whatever it is. Now, I have a lot of stuff. Now, I have the ancient texts about the things that were written, and I think those are the things that are most important to understand. And a few things have just popped up recently that are so unbelievable that they have to be seen to be believed. And you will. And what I'm asking for is for someone to step up and say, yes, I will set up an administration to do this stuff. I want to contribute as far as my research goes, my specimens, my knowledge of what I have done up to this point. I'm too old to get too deep into this. Somebody's got to carry this on. You know, if I go, it's all over, case closed, as far as this goes. I mean, there's a lot of people looking into things now, but they're sort of, everybody's going their own way, you know, and I understand that. There's no real cohesive thinking on this, because a lot of people equate this and giants and all of the things that were written about into the religious, which I do too. At this point, I see it all as involved with gods, with everything. There's nothing off the table at this point. And something that is very interesting is the flip over spin of it's called a Jerenkov, something like that, how you spin, something spins, and then it flip right over, and spin, and it flip right over. And they're saying that might happen to the Earth, and I've been studying that, and doing that for the last year or so, studying how this Earth is scrubbing as it spins into these particles coming at it. And then my son gives me this book today, and I open it up. This is about ancient mysteries, and it's all kinds of stuff. He gives me good stuff. And I just basically open it up, boop, it pops to here, topsy-turvy world. This is the spin. If you take this ball and you go spin, it starts spinning like this, and then all of a sudden it flips over, so instead of the peg going that way, the peg is now going this way. It's still spinning the same direction, you see it? But the top, can you see, am I holding this in the right place? The top flips over, and now it's upside down. And it flips over instantly. And I show this, well, let me show it to you, because it's stunning. And they say this is possibly something that can happen to the Earth, and I don't see any reason to discount that. So, but that's what I've been studying, the ether and how we, I forget how far I've gotten into this, but it's all about electron flood theory and how we're interacting with the particles that are in space. There's just a billion zillion particles out there. We know that. They scrub creating our ionosphere, the out magnetosphere. We're rubbing and scrubbing through them, creating these interactions out there, these energetic interactions. Now, what exactly do they equate to? What is the Van Allen belt? What does it all mean when you get down into electron flood theory? All right, and what do particles look like? What does light look like? What do electrons look like? All right, they look like something. And I could show you the light experiments that I did with Rod Warren regarding the Venturi and accelerating the particles and then having them explode, and then actually having the black and white particles display as photons just like this. Actually, we can see them, actually see them. As they start to accelerate, just before they concuss, they expose themselves as being this box of particles. Prior to that, you could see a little red and white and so forth, but just before here, boom, they show right up. And I believe they explode into actual electrons, which this would kill you coming through the atmosphere, or it would collect on you as static. But if there was enough of them amassed in one area and they came through you, they would explode the material in you, because they rush through particles that oppose them, resistance. All right, if it went through copper, well, it'd just go through copper. But as soon as it hit you, and then it had to get you through to get to ground or back to the other side of that electric circuit, you would be exploded, because your body resists that flow. It says, no, you can't come through here. I got all the electrons I want. And they say, I don't care, I'm coming through. And they said, well, you're going to have to explode the water. And I said, no problem. Boom! The water explodes, sizzle, pop, all kinds of things. Heat, combustion. That is when you push too many electrons through some place doesn't want them. If you're pushing it through the copper wire, it goes, because there's a ton of extra copper, extra electrons just floating around in there that are part of that molecular structure. Some things are conductive. Some things are resistive. It's just all it is. Some things say, no, I got all the electrons I want. I don't have any extra electrons for you to come pushing through with. So stay out of here or you're going to break me. And they say, well, we'll come through and I'm going to break you. And they do, and that's electrocution. It's lightning strikes. They cause all fires and everything else. That's because their particles are forcing themselves through the network of other particles. Now, when we shoot it here, they actually have to expose themselves. Normally there's a region around here. I should probably show this as a region around here, because that's what they do. They control a big region. And when they hit in, something else hits that region. Like here, I should have... oh, here it is. You see, I told you they look like this. They look like that. Right? This is what they actually look like, right here. Now, outside this mass of particles, and that's what they are, there's one that has no energy whatsoever, and there's one that's extremely concussive, and when you put them back to back, each one of them is an electron, they make a photon. The photon is not necessarily deadly. It lights things up, it warms things up, it concusses, but when you put it in its electron form, it wants to bond with something. Here it's like bonded, it's loosely bonded, and this will flow into something and create heat and so forth, but it doesn't do like just raw electrons in mass. Raw electrons, they're all over the place, everywhere. And those are heat. And when they go together like this, and they're moving fast and concussing with things, they can get to all the way up to light and so forth. All they are is moving particles, and it depends on how fast they're moving, how much energy they're going to give off when they hit something. Basically, it's as simple as that. And a big chunk like this, It's different than the particles of light. Light is all in here. It's a little tricky to talk about. That's why we need some classrooms. And I mean, this is just a mess. It's just what I do, and that's how I do it. But what you got to get into the understanding of. The nucleus is like this. Positives go towards the center, surrounded by negatives that really want to be away from each other as far away as they can get. That's why I believe they're mostly clustered to the outside edges. So mostly the positives are in here. That's why they still want to get more negatives to go to that positive. We're going to see that in tractor beam magnets in a minute. And they pull up, but these negatives say, no, you're going to have to stay exactly that distance away, because we have plenty of positives and negatives right now. I know you want to get to those positives in the center, but you can't come. You have to stay that far away, because I am pushing you away. It's push to shove. All right, let's look at that. Okay, my friends, we are going to get into everything, and we are going to start with atomic theory. The Bohr model has been proven wrong, 100% certain. Now, I say everything is made of the smallest particles there are, which the smallest particles there are made from light, and they're made together. A couple of them make photons of light, and they spin. And I have shown this in the light experiments and the actual photographs of these spinning particles, and how they concuss and how they separate from the strong and the weak force. And we're going to look at that in a minute. Now, I keep saying, get your book, right. Well, yes, I've been using these books. I used to, and what you should do, I would recommend, if you're just getting started into this, is what I used to do. And you can see this goes back a while. I mean, back to just after they had papyrus, you know. Now, this was, what you can do this with this way, having these 3-ring things. You know, there's a lot to this, and it gets pretty complicated. And, you know, you want to make a lot of notes, and you want to make a lot of information for yourself. This very detailed. You see this? This is all pretty serious stuff. Now, you don't just write that and then you're all done. So what I'm saying is that your best bet is to get this kind of stuff. And then you can make mistakes and throw the paper away, and then fix it back up and make yourself notes that are meaningful. And these are all meaningful to me. I'm telling you right now, these are all meaningful notes to me. They look like all just silly stuff, but this is about oxidation or reduction, oxidizing agents and reduction agents. This is all very good information. Now, I just want you to make sure you document this. That's my point. I don't care how you do it. I use these books, and then I put these little tabs on them saying that this is about this is about this, and so forth. And that way there, if I make mistakes, I make mistakes. I don't care. I put a big X across it. It's no big deal. But I can at least go back and see what I was thinking about. Because right now, I'm going to tell you right now, there's a strong force, there's a weak force. And I could show it to you. I have a zillion, billion times. And you could see them. And between 2 of these back to back, one this way and the other one another way, just like this, is a photon. This is the electron. Right? When these go through the air, the photons, they spin, because one side is concussive, the strong, and the weak isn't. So it bangs one side and the other side doesn't, so they start to spin. Now, there's a right-hand rule, and that means they spin this way, just like this. If the electron's going this way, here's the electron. This is its trajectory. Now, this is not just shows you where it went. It's only here. So it goes bzzz, and the only thing that exists is the particle. Now, just exactly like you're seeing there. This is the right-hand rules. And if you put your hand this way and put your thumb that way, it means the electron's going this way and the spin is this way. All right, now, the right-hand rule. And we see this. And that's the reason for all of these push to shove. Everything is push to shove. All right? and it causes stable spins. You push me, I shove you back. You push me, I shove you back, and it spins me around in a circle. Now, I will explain this the best I can. The black has no impact, but it wants to be attached to the white, so the thing starts to spin. And when they start to form clusters, they start to spin at different rates and different frequencies, and we'll talk about that. Although I do want to try to understand why a right-hand spin versus a left-hand spin. I do see every now and then one that looks like it's spinning backwards. We'll talk about that. But these are together, and then they're together in chunks like this. Really, when you see something coming through the air at you, light, it's like this. And I can show you this, and I have, and I will, and I'm shown it a bazillion times. Now, that won't kill you. That if you have a lot of them coming in at the same time, it'll warm you up. That's like light. But light is warm. Sunlight just warms you up. Now, if you have these coming through the air at you, that's lightning. That's static electricity. That's electricity that has nobody to hold on to. It wants to be incorporated into something. Lonely little guy out there all by itself. It wants to attach to something. It'll attach as static, no big deal. But if you have a bazillion of these particles in the air and they have nowhere to go and they start to collect and actually ball lightning is the same as what happens. They start to collect in a ball, literally. And then all of a sudden they come down to earth as lightning. Now, normally you're not going to see them start as the ball, but it could. And now they're seeing the sprites go up because the layer of atmosphere between the frequencies, which they call the Schumann frequencies, fills that static layer. So full of electrons that it wants to go down, but below there's so many electrons, it says, no, we don't want you. It tries to go up, and that's what's called a sprite. They get brilliant, bright red lights, and then they dribble back down because it can't take them anymore. We will see that too. But this is the interaction, this right-handed spin, and I will show you, well, let's look at it now. All right. I almost show exclusively Rod Warren's work when I'm talking about electron flood theory, because he so fabulously shows it. Now, he's using a Venturi, which is nothing more than this with another one over here. And then the light coming through, just like this is. You see this? That's a white disk. Right, that is a white field. What does that mean, Roger? Well, it means that it has all of the colors, instead of just having the green or the red or the blue, which is primarily what we work with. It has all the colors. You see all these colors here? That's blue, that's green, that's red, that's blue, that's green, that's red, that's blue, that's green, that's red. They're splaying out. Well, what does that mean? It means that they are different frequencies and they have different impact values, but when you add them together you end up with a disk like this. Now, again, this is a half of Venturi. Now, Rod normally has a Venturi that is literally the same architecture, a round nail, literally a nail, and another literal nail right there, metal. Boom, the light comes through. Only the white comes through, and we see the brilliant, brilliant looking white stuff. Now, however, we're seeing exaggerated red in my mind. This appears to be the multiple frequencies of color. There's a lot to look at here. But my point is, you see this down here? I don't know if you can see that in the camera or not. But there's a shade of this. This one here is twisting. You see it? Yeah, maybe if you get way back here, I can see it from where I am. I don't know about you. Anyway, all very, very interesting stuff. Now, the reason you're seeing these colors so vividly on these cell phones is because they have something, I believe they're using what's called thin film photography, and it only allows certain frequencies to come through, and then it can really, really look at them nicely. And that's why you're getting these separations of frequencies so elegantly in these photographs. I mean, the stuff Rod's sending me, or he's pretty much done sending me stuff because I've just seen almost everything there is to see. No, I'm just kidding you. There is so much to see. But I mean, I have seen so much. It's just absolutely stunning. And I have other people like Renz. Bonjour, Renz. He's over in France. And I believe Fabien Boulet is over in France too, who sent me ones showing the red and the green going through the laser, through the Venturi at the same time, showing how different the concussion is and how they actually interfere with each other. Very, very interesting how much more powerful green is than red. Although there's other things to take into account, is the intensity of the actual laser, because I have them here, and some of these are real powerful compared to other ones. I really haven't tested it, but I'm pretty sure they are. And anyway, this is what this is coming at us. You see that? That's this. Right? And everything relates to frequencies, magnetism, push to shove. You can have it push or you can have it pull. And we got a lot of dancing to do, Lucy. This is going to be a while. Now, I think kids are going to love this, because I'm going to speak to, like, you're 8 years old, you never heard of the word electron before, you just barely learned to spell, you know, addition is probably right up there with you at this point. I'm not expecting any much more than that. You don't need much more than that. And I'm talking whole numbers. I'm telling you, you really get the kids, they will love this. Look, because, you know, you look at this, you don't see this. What do you see here? What do you see here? You see nothing. It's all here. It's all right here in front of you. You cannot see. You are unable to see. You don't have a clue of how powerful things are that are just in the air and just waiting to do something. All right? And I say the nucleus of every atom is made of particles like this, not gigantic neutrons and protons. Every neutron is 1,838 of these little particles, 1,838 of them. And every one of these little particles, see that, is a plus and a minus. It's a magnet. They're all bar magnets. Just like they were all bar magnets, whoops, like that, all attached together. Now, you can make them push apart. See, right now I got them pushing apart. But I can make them snap together. Now, it depends on, we got just a lot to do, a lot to do. So let's just move on forward, my wonderful friends. I'm just doing this for fun for myself. If you want to do it, good. But there's a lot, I think, that I am going to present that is going to be different than what you're going to hear elsewhere. Now, I'm going to present it both ways. I'm going to say, here's what they say is happening. And I can't, my dog's got to eat here. I got to go. Okay, my friends, I am going to close this case in less than like 5 minutes. This is electron showers. They call them electron neutrinos. If you could know what's going on from the other side of this Venturi, and a Venturi is this, right here. It's nothing more than 2 metal pins, and the light from that red laser is coming through here, and all of this is the showers of particles that it makes, and we'll see that in a second. This is a reverse spinner. That is extremely important. You see the colors of these, all red primarily. That's changed a little bit of color because it's squished. It's all impact value. Now, that's red laser. It's light. I'm going to show you it accelerates, and then we're going to see something extraordinary. Well, this is kind of extraordinary. Okay, very simple pulse red laser. Bip, bip, bip. I was always told light is light. That's light. Now, I say the particle truly is like this. And there's a concussive white part, and then there's a non-concussive black part. And each one of these is a particle. And this will now become accelerated as it becomes pulled through the venturi, which I showed you before. Now that venturi before I showed you was here, and it's like this, right here. All right, so this is the particle wave I just showed you, pip, 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 which is nothing more than these particles. Now, these particles now are becoming accelerated and literally being pulled out of the wave because they are forced through this venturi, which is a restriction that is well understood how that works. And it accelerated gasoline in the carbureted engines. Now, there's the particle. Now, as it gets closer and closer, it gets brighter and brighter and brighter until it's just explosive. And when I say explosive, I mean explosive, because not only does it glow, it separates the black from the white. And you say, ooh, Roger, what black and what white? And I say, well, it's a good thing you asked me about that, because this is the black and the white, if I can find it. It's around here somewhere. Well, let's just look at this. I just showed you the wave, I showed you the acceleration, I showed you the explosion, I said there's a particle, there it is. Now, that is the particle, and what it does, and when I say it's a particle, it's more than one particle, it's a box of particles. And I think there's 4 particles, but it could just be 2. Positive and negative, that, you know, that type of thing, back to back. Now, when they hit the venturi over here, they explode, and I will show you that, and I think I probably already have. This is the particle, whoops, spinning to the right, which means it would drift to the left as it's being taken a picture of. It's all that at once. Now you can see it's slowing down, so that's right after the venturi. Now, what else can we take away? This was the particles coming at us, as I said. Now don't forget, these are red. It's because we started with a red laser. Now, if we had sunlight, what color would they be? Huh? What sunlight is white. Now, let's see if we can prove that. Now, remember this one, because this is the one that I said I thought was a white particle. I think I've said that a while ago. And then it does this when it interacts with another field. These are fields. And wherever you see the most glow, it means the most impact. The most impact means the most energy. The most energy means something's pushing harder against something else. It's simple as that. All right, remember I said before it hits the venturi and explodes. Well, here they start to come in, and until they get real close to the venturi, they're not so excited, and you really can't see a whole lot of definition. Then you get here just before the venturi. Then they start to show themselves as the particles that they are. You see those, the black and white? And here you don't quite have the really concussion yet. You don't see the spikes. But then in this closer, shot, you see the black and white spikes coming up because it's really starting to concuss. And then it gets real bright over here, and this is where it separates going into the venturi. Can you see that? No, probably can't. All right, now you can see it. This is where it separates coming into the venturi, and then that's when you get the black and the white particles. Okay, I think I might have mentioned that what you would see if you had all of the frequencies of light, the red, blue, and the green, which we do have here, in the sunlight, you would see white Higgs fields, which are the magnetic fields that are the impact values of the particles that are hitting what's in front of them. Well, these have impact values relating to all the frequencies of the light, all these different frequencies, so we get a white. Now, why are we seeing this field? You don't normally see that when you look up in the light. Well, what Renz did, bonjour Renz, it's my friend over there in France, Renz. Now, he put his finger up like this. Instead of what Rod had, which is 2 fingers, Rod had 2 circles just like this, and the stuff was forced through and it made a spray. Well, Renz has 1, and with this other one, and it made a thing, and it also flopped off and started to go sideways. Watch this. You see this? I don't know if you can see it in your shot, but it starts to go sideways, you see? And it's starting to, it's like, it's laying off this way, twisting. Now, the reason this was so interesting to me is because of this tennis racket effect, where if you, or a hammer or anything, you spin it up in the air like that. When you spin it on the certain axis, it not only spins, it twists. And this is the same thing here. Now, I believe it's got to do with the interaction of the fields. It has to be. So, and it's got something to do with the right-hand rule, because I did. Here, I did this. I threw this, and it ended up twisting like this. All right? Because if you throw it up in the air, what will happen? Here's what happens. You throw this up in the air, so the forward motion is this way. This will go up in the air, and it will spin, and you'll catch it, because it'll spin up in the air, and you'll catch it in your hand, and it will have made a half a turn. You do it again, it'll go up, and it'll come back down and make another half a turn. I'll maybe show a video of doing it, but you can find it on, I forget how to pronounce the name. I think it's called Jenna Bekoff's. And I think they spell that with a D, but I have it down here with a J. Jenna Bekoff's, Dana Bekoff, something like that. And when you throw it up in the air, it spins around half a spin. At the same time that it goes this way up and around, it spins sideways. If you have an axis that's like this. If it's on this axis, it doesn't do that. But if you have a wide axis here and you have to plow through the air with that, it spins it sideways. That's what I'm seeing. And electron flood theory, we're going to look into it. Hold on. We're going to look at why it spins and why it bangs into all of these different particles and why the rotation changes as it spins. All right, it's a secret right now. All right, we'll figure it out. The Russians kept it secret for 10 years. I'm not kidding you. What happened was this guy went up there to do something on the Russian space station, and he'd take the nuts and bolts or whatever they were, the wing nuts, he went, psst, and went, shh, boom, and then it flipped over, and it went, shh, boom, and it flipped over again, shh, boom, and he didn't touch it. It was going spin, 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 and then it would completely turn over. Spin, 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 completely turn over again. Spin, 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 and he had no idea. And you look at it, it's the strangest looking thing. I think I probably showed it to you, but it is strange as hell. Now, I looked at it, and it's got to be something is building up to a point that it says, hey, you know, it's got to be a pushback. It has to be a pushback. This is intriguing. I gotta tell you, I am intrigued as hell because it is such a bizarre effect. And it is possibly what's happening to the Earth, which, you know, our pole is shifting very fast compared to what they expected. We are overheating, and I'm almost 100% sure just before it flips, there is an energy increase. If you could see the very, 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 very minute changes of energy particles, I bet you'd see it go zzz, and get a little whiter and whiter, and then it would flip, and then it would get darker, and then a little whiter and whiter, and then flip and get darker. I believe that's what you'd see. I don't have the equipment to see it. That would be my prediction.